The next doctrine we want to use to understand logical empiricism is its most famous or infamous attempt to understand meaning, the verificationist criterion of meaning. Early positivists held that the meaning of a proposition is the method of its verification. All seeming statements that couldn't be cashed out in terms of conditions for their verification were meaningless. This principle was often invoked by the positivists to critique philosophic problems as pseudo-problems. For example, A.J. Ayer was once interviewed on a BBC radio show and asked, "So, Dr. Ayer, we understand that you're an atheist." To which Ayer responded, No, I'm not an atheist because the phrase God has no meaning. There is no set of conditions that would verify the existence or non-existence of this entity, and hence the word has no significance. So, theoretical terms, as well as the variables and observable terms in any given scientific law, are going to get their meaning by the operations, the conditions that we use to verify their existence, their qualitative or their quantitative value. The final doctrine, then, is the unity of science. And the unity of science was held by a lot of early positivists. Most positivists at that time held that all of the sciences could be either reduced to or conducted in the same manner as physics. And the idea was that just as elemental chemistry was reduced to molecular chemistry, which was reduced to atomic chemistry, which ultimately was just an expression of physics, every legitimate science would have its covering laws from the specific domains within that science reduced to covering laws and terms within the next lower science, working its way all the way down until all of the sciences were subsumed under the rubric of physics. Physics itself gets its terms cashed out in terms of a ontologically neutral observation language. Now, how would this work in practice? Well, suppose that I want to use Hebb's law. I want to, in fact, determine what the reaction potential is between some stimulus and response in a particular environment for a particular organism. Now, the first thing I need to do is come up with operationalization of what counts as the same stimulus and the same response, since both expectancy and habit need those categories. Then, since expectancy is a non-observable property, that is, it's the probability of the subject manifesting a learned response in a particular environment, I'm going to have to operationalize or give conditions for its verification in terms of how it gets calculated. I calculate the expectancy by determining the habit strength. And again, this is a non-observational term, and so I'll have to come up with an operationalization for that, and then I multiply the habit strength times the drive, which again is a non-observational term that I'll need to operationalize. So in the case of habit strength, I'll operationalize HSR as being proportional to the number of stimulus response pairings that the organism has experienced in the past. So I'll just count pairings of stimulus and response. I'll multiply that number times my D, my drive. And again, I'll have to operationalize that. I might operationalize it as, say, in the case of hunger, how long has it been since my experimental animal has eaten? Once I do that, then I've got a way of going from my initial condition S to my desired explanation or prediction of expectancy. Now, all of those terms are couched in my rat psychology, but ultimately they'll be cashed out somehow in the physiology, usually by my operationalizations and how those operationalizations are related to physiological terms. So when I go down to the next lower level, the physiological level, there'll be law-like relationships between H and D and expectancy and lower level physiological terms that I use to cash those higher level terms out. Now, the story we've just told is a story that for the unity of science will be repeated over and over and over again. Theoretical terms and dynamic relationships between them in a higher level of science will be reduced to via law-like relationships between their constitutive categories, the theoretical terms and law-like relationships in a lower level science. Now this will be a lot like compiling programs into machine language. Each step down will likely involve a more complicated picture relating more items in a more complicated fashion. But ultimately, all of these theoretical terms and the dynamical relationships will be grounded in physics, and physics itself will be grounded in the ontologically neutral observation language. Thus, for the logical empiricists, the epistemic structure of science is such that the certainty of immediate experience cast out in ontologically neutral fashion, together with the certainty of rational intuition, is what translates up through the structure of science to give it its epistemic status at every level. Hence, the structure of science, according to the unity of science, is going to look something like this. Every legitimate science that has covering laws collected together into the domain-specific axiom systems, like, say, ideally, sociology, will have those systems reduced to the covering laws of domain-specific axiom systems in the next lower science. Sociology will presumably fall under psychology, psychology under biology, biology under molecular biology, molecular biology under chemistry, chemistry under physics, and everything is grounded in the observation language. Now, in the next lecture, we'll take a look at how Hempel translates this general framework into a logical behaviorism.